So we got cut off in the middle of the last example, so let's review what we were doing. A large pizza has a diameter of 14 inches, so a radius of 7 inches. Therefore, its area was pi r squared. Pi times 7 squared was 49 times pi, which came out to 153.94 square inches. Let's just check that value using a different calculator. Let me hit clear. So in the calculator, the TI-84 calculator, I would type in 49 times, to use the pi key, I would hit second, and I can see the pi key's in blue right here, which is why I had to hit second. Then this key right here. Okay, so yes, it was 153.938 or 0.94. And the units on that were square inches. So let's compute the value of this pizza now. It was $12 per 153.94 square inches. So we're going to divide those two values to get the amount per square inch. So let's take 12 divided by that value. And instead of retyping it, I can hit second again, and the A and S, see it's blue down in here? This key right here is the second answer to divide it by the value on the line above. A and S just stands for the answer from the previous line. So I'll divide those two and I'll get 0.07795. So that's about 8 cents if I round up. I'm going to leave it exact to about 4 or 5 decimal places right now so that I can compare this value with the value from the medium pizza. Alright, so let's look at our values for the medium pizza. The medium pizza has a 7-inch diameter, which means that it's going to have half that, or 3.5, as its radius. When I'm finding the area, I need to know the radius. The formula for area is pi times radius squared. Let's go back to the calculator. So we're going to take 3.5 squared. 3.5 squared is 12.25. 12.25 pi is the exact value for that area, and it's approximately, let's multiply it by pi, approximately 38.4845. Square inches. Okay, and again, I need the value. So the cost of this pizza was $5 divided by that 38.48. So we're going to take $5 divided by that answer from the line above, and we get 0.1299. 0.1299. I messed up my units over here. This is per square inch for the units. When I divide things, the units on the top were dollars, the units on the bottom were square inches. The units for the answer should be the units on the top divided by the units on the bottom. So the units on this are dollars per square inch. I need to be careful with that, making sure I show my units correctly. So, which one's the better buy? Well, not surprisingly, I suppose, it's the large pizza. That's the better buy. That one is about 8 cents per square inch. The other one costs us about 13 cents per square inch. So you actually get a measurement of how much better it is, which is also useful. Alright, the next objective, we're looking at problems involving surface area and volume. So the first shape is going to be a rectangular box, and the measurements on this shape will be length, width, and height. The formula for the volume of this box is length times width times height. Very similar to area, length times width, but we also multiply by that third dimension, height. Now the surface area of this box is the area of each of the walls of this box. Now there are three pairs, a front and a back, a side and a side, and a top and a bottom. So let's look at front and back first. They're going to be the same, so we've got 2, and the side that is the front has a height and a length. It's going to be 2 length times height. Look at the side next. This one is width by height, so 2 width times height, plus top and bottom have dimensions length and width, so 2 length times width. So that whole thing is the formula for surface area. Just 2 of each of the 3 types of sides. 2 length height, 2 width height, and 2 length width. In the next example, we want to find the surface area and volume. Okay, so the surface area would be 2 length times height, so 2, 7 times 4, plus 2 width times height, so 2 times 4, plus 2 length times width, or 7 times 2. So we've got 2 times 7 times 4 is 28, plus 2 times 8, plus 2 times 14, so 56, plus 16, plus 28. Let's just add those up quickly. 56 plus 16 plus 28 comes out to 100 even. So my surface area is 100 inches squared. This surface area is a measurement of area, so the units will be square inches. Next, we need the volume. Volume is length times width times height, so 7 times 2 times 4. 7 times 2 times 4, well I know 2 times 4 is 8, times 7 is 56. And it's volume, so the units are inches cubed. Filling in the 3-dimensional space will be in cubic inches. Surface area really is only filling in a 2-dimensional space, and it's filling in just the side of each edge of the box. Think about it as painting a room versus filling the room full of bouncy balls or something. If you paint the room, you're painting 6 different 2-dimensional sides. If you're filling it up, you're filling in a 3-dimensional space. Alright, so we've just looked at the box. The box is the simplest case of a prism, and a prism is an object that has 2 parallel ends of the same shape. So another word for box would be rectangular prism. Alright, this is an example of a hexagonal prism, and this right here would be an example of a triangular prism. We're going to look at the formula for a triangular prism next. Alright, so the way the volume formula worked for the box was it was length times width times height, and length times width was already the area of the base right here. In a triangular prism, the area of the triangle is 1/2 base times height, and we just need to multiply it by the length of the prism, so times length. 1/2 base times height times the length. Alright, next. Let's find the volume of this prism. So 1/2 base times height for the area of the triangle. So 1/2 times 6 times 4 times 12, the length of the prism. Half of 6 is 3. 3 times 4 is 12. Times 12 is 144. It's volume again, so the units will be cubed. So I have 144 cubic meters. Alright, in this prism here, it's a trapezoidal prism. If I want to find its volume, it's the area of the base times the length. The length of the prism is 6. In the area of the base, the formula was average the bases and multiply by height. The average of the bases are little b and big B of this trapezoid. So it's going to be 2 plus 5 over 2, average the bases, then multiply by the height of the trapezoid, times 3. Okay, so for the area of the base, average of the bases times the height, and then times the length of the prism. So notice that I had some extra information in here that I didn't need. In order to find the area of that trapezoid, I didn't need to know how long that diagonal side was. I just needed the 2 bases and the height. So this is 7/2 times 3 times 6. Alright, so 7/2 times 18, and then I can reduce. I know that 2 goes into 18 9 times, so my final answer is 7 times 9, or 63 centimeters cubed. Next. Finding the surface area of this prism is just a matter of finding the area of all of the surfaces. Okay, so this prism has 2 triangular ends and 3 different rectangular walls. So what is the area of the triangular end? Okay, I've already found that, but the area of the triangular end is 1/2 times the base of 6 times the height of 4. So we said that was 1/2 of 6 is 3 times 4 is 12. Okay, that was the area of the triangular ends. What would be the area of the rectangular sides? Okay, so this triangle right here is going to be a triangle that has all sides being the same. These weren't labeled, so I'm going to assume that they are the same. So this rectangle right here is 12 by 6. All of them are actually 12 by 6. Oops. So I'm going to have area of the rectangular sides being length times width, 12 times 6. And 12 times 6, oops, I need to turn the calculator back on. 12 times 6 is 72. Okay, so when we put that all together, the surface area is going to be the sum of 2 triangles, so 2 times 12, plus 3 rectangles, so 3 times 72. So 2 times 12 plus 3 times 72 is 240. So 240, this is in meters, and since surface area is a type of area, it's going to be square meters. Make sure that you use the appropriate units, whether it's square, cubed, or regular meters. In the case of area, it should be square. Alright. Similarly, in the next one, we're going to look for the surface area. So in this surface, we have top and bottom, which are the same. Then we're going to have 4 rectangles, but not all the same measurements in this one. So let's start. Okay, I'm going to start with my 2 trapezoids. The trapezoid formula was the average of the bases, so 2 plus 5 over 2, times the height, which was 3. So right now that's 2 trapezoids. Now let's look at these rectangles. This rectangle is going to be the same as the one on the opposite edge. So there's going to be 2 of those. Those have length 6 and width 3.5. 6 times 3.5.